Hello.
KVNP. KVNASP Prasad.
Hello. Hello,
Oh,
sir.
good morning, sir. Sir, tell me,
Good
sir.
morning. My screen is visible?
Yes, sir. Yes, sir. Visible, sir.
Okay. Right.
Visible, sir.
Okay, okay.
Okay.
Shall we start or need to wait for
Sir,
some?
2 minutes, sir.
Yeah.
2 minutes.
A brief introduction will be there, sir. Just.
Sir, I am able to hear. Are you able to hear me, sir?
Yeah, yes, madam. You can start.
Distinguished guests, respected principal, head of the department, esteemed faculty members, and dear participants, a very good morning. I am Manasa, working as an assistant professor in the Department of ECS. On behalf of the organizing committee, welcome you all to this 5-day FDP on the future of computing, emerging technologies and trends. I deem it an honor to introduce the resource person for today's session. Dr. Tene Ramakrishnadu is currently working as an associate professor in the Department of Computer Science and Engineering, National Institute of Technology, Warangal. He received the B.Tech in Computer Science and Engineering from JNTU, Hyderabad in 2001. M.Tech in Computer Science and Technology from College of Engineering, Andhra University, Visakhapatnam in 2004, and PhD in Computer Science from the Department of Computer Science and Engineering, National Institute of Technology, Warangal in 2016. He joined NIT Warangal in 2006 as a lecturer in the Department of Computer Science and Engineering. He has 20 years of teaching experience in teaching various computer science and engineering papers offered in B.Tech, M.Tech, and MCA curricula. He has published several research papers in international conferences and journals. At present, 7 PhD scholars are working under his guidance in the fields of big data analytics, data science, machine learning, and natural language processing. Currently, he is executing an R&D project in the field of data science and machine learning sponsored by SARB. He has served as the program committee member for many international conferences like IEEE Indicon, IEEE CGVIS, etc., and also served as the session chair for an international conference like UKAIS 2018 held at the University of Oxford, London, UK. T. Ramakrishnadu is a resource person to many faculty development programs or workshops sponsored by UGC, AICTE, TEQIP, DITY, ATAL, etc., organized at NIT Warangal and other engineering colleges in India. Presently, he is a member of the Board of Studies and member of Research Advisory Committee for many engineering colleges in India and a member of Standardization in Artificial Intelligence Technologies Working Group, Department of Telecommunications, GOI. He is a member of the IEEE Computer Society Technical Committee on Data Engineering, ACM, CSI, and UACEE. He was a technical team member for the national level entrance test NIMSET 2012 and NIMSET 2013. His current research interests include distributed data mining, big data analytics, web mining, text mining, social media analysis, large-scale machine learning, natural language processing, and recommendation systems. Now I'll hand over the session to Sri G.K. Nagaraju.
Thank you, madam. Sir, shall we take the session, sir? T. Ramakrishnan, sir.
Yeah, sure.
Uh,
Thank you, ma'am. Thanks for the introduction. At outset, let me congratulate the organizing team at GPREC Kernel, principal of GPREC, and head future computing technologies or something, emerging technologies, and the faculty members and the participants who are attending this course. Okay. So thanks for the invitation. And this course is completely a fundamental and a beginner's course because this is very short duration. It's not possible to cover the entire natural language processing because it's a very big subject. We need at least 40 to 80 hours to complete the NLP. We are handling at our side this in 2 sessions, 2 semesters. Each semester is a 40 hours duration. So to complete the entire NLP. So at present, there's a lot of scope to do research in NLP. So during my session, I'll give some directions to the new researchers, young researchers, those who are planning to do the research or those who are doing the research in similar kind of domain. And also, what are the open problems in NLP? How to start research in NLP? What are the applications of this NLP? And what are the tasks in NLP? This NLP tasks. If you want to build your own NLP system, what you need to do? Your own NLP model, what you need to do, where you need to start. So this is the plan for today's this 2 to 3 hours lecture. And to reduce the bandwidth, I'm switch offing my camera because I'm running this from my home. Here some issues are there, network issues. Okay. And in between, please respond to my questions. Otherwise, there is no use of spending my time because these online things, maximum of the participants are simply joining the meeting and not spending time on that. Okay, please respond to me. So let us start with the basics. So those who are new, I'm assuming that all the participants are new to this. Because every participant should understand at least a delta portion of from this lecture. It's not like only those who are familiar with this. It is completely beginners. Everybody should understand. And coming to the prerequisites before starting this NLP, actual NLP, the prerequisites for this, suppose you are new to the domain, you want to start learning or doing research in this particular domain, no need of any prerequisites for this except learning algorithms like the machine learning algorithms. So parallelly, machine learning and this NLP, at the advanced stage, you need to get the concepts from deep learning. So parallel, both the things, the NLP and the machine learning, together you can start learning. Then after that, you can start your own research. So let us see what is natural language. So we're all talking in different languages. One is English, another one is Telugu and Hindi. These are all the languages, natural languages. So I received it. Sorry, just a minute. Okay, right. Sorry for the interrupt because today is working day. We are on duty, so we may get interrupted calls in between. Okay. Right. Let us start. What it is exactly the natural language? The language allow humans to record and reproduce ideas. So, something. Any idea or any discussion or any communication that we are going to record it and we are going to reproduce. Where we are going to record? We are going to record in our brain and we are going to reproduce. That means for a given question, we are going to answer. And when it comes to the digital or when it comes to the actual written language, these are recorded in multiple forms. One is the spoken words. So what I'm talking is recorded. Yes. And when I'm writing something on paper, I'm recording on that. So that's the one form. Here the spoken words is the one form, and another one is the written words. Maximum of the humans are thinking that the natural language is the spoken and the written kind of. But some people will communicate through gestures and signs. Did you observe this dumb and deaf people will use their own language, that is the sign language. That is also a natural language. So here I want to give, before starting the concepts itself, I want to give some idea to the researchers. Now the entire world, this NLP world, is thinking about the written text and the spoken. But recently, a few researchers started focusing on these gestures and signs. So processing that is also a natural language. Processing, something like, suppose a dumb person is unable to speak, that's why he's using different sign symbols, and through that is communicating with others. So now what can be done at the computing side? As a computing professional, what kind of task we can develop or we can do it? So converting the sign symbols, suppose somebody is showing a sign symbol and converting that into the text immediately, and the text form converting into the audio form. So those who are unable to read the text can listen. Those who are unable to speak can show with the can communicate with the gestures. Now the current NLP is focusing on this in addition to the other tasks. So what are the different forms? One is the spoken words, the written words, and the gestures and signs, or the digitized form, that is the text form, such as text, audio, and the video. These are all the different forms of communication in the natural language. Now if you want to do the natural language processing, you want to build a model or a system, what kind of system you want? You need to decide what is your input data. Sorry. Input is the text data. From where it's coming, the text data. Suppose you want to analyze the financial document. You want to analyze the financial document prepared and written by the different auditors. In general, auditors will give their report on the transactions done in a particular organization. Now you want to analyze the data. Or let me give an example. You want to analyze the legal documents. Now currently some of the researchers are working processing the legal documents. The documents from the maybe from collected from court, maybe the judgments. Want to process that. So what kind of data you are trying to process it? It's a text data. And from where it's coming? Based on the application. or general thing, something like you want to analyze your what is it, data available on a particular website, or you want to do some analysis on the blog, microblog. These are all the text. Now, what kind of task you are doing it here? One is understanding the text. Okay. Then reproducing the text in the form of output or some other text. That means you are doing a task. That task is text to text. This NLP task is your input is a text, and your model will accept this as an input, and it's going to produce output. Both are text, text to text, text to text. These days, there is a buzzword, generative AI. You heard the term generative AI? Please respond to me. Let me understand whether you are following or not. In text form or what is this? Somebody please respond. Yes, yeah. Astakamad. Okay, you heard that. What you are generating? So this task comes under the generative AI. If you're using AI models to generate, just a minute. This is coming. Okay, right. Yeah, this is a generative. You are converting text into a text. Maybe translation, machine translation. It's going to read the text in one language, it's going to produce the text in another language. It's a text to text generation. Application of generative AI. Let us come back to the other forms, audio form. So your model is accepting audio as an input. It means you want to understand the audio. Just analyzing the audio, understanding the audio and analyzing the audio. Maybe the target is understanding the emotions of a particular person while talking. What are the emotions? It's emotion detection from audio. That is the voice data. Analyzing the voice data and understanding that. There it's just processing only, natural language processing. But also you can do in NLP, you read voice, there's an audio as an input and produce text as an output. Audio to text. So when I'm talking, so when I'm giving the lecture, my voice automatically should convert into the text and it should be displayed in the text form. Right. Not only that, bit advanced. So in crime investigations, many times these people use something like they want to know the approximate the people, those who are involved in the crime, based on the person or something like who is giving the basic details of the crime person. Something like the void, with a audio is giving the brief picture of the person. Something like a person is a middle-aged, long nose and short hair and wearing a particular kind of shirt. So when you are giving that as an input to your model, based on the voice, it should image, audio to image. So generating inside that NLP is acting for understanding and generation. So audio to text and audio to image. Reverse text to audio. So when I'm supplying the text, I should get the audio. In these days, we are using some applications like the screen reader. So based on the text, it's going to produce the audio, reading the text. How it's happening? What kind of task is running behind that? The same NLP task is running. And another one is text to image. So in the text, you are given the description of a particular scenery, maybe something like in a picture, or something from your mind. Your imagination is something like a picture. Background is green background. One tree is there. Under the tree, a old or middle-aged person is sitting. Near the tree, kids are playing, and near that, few birds and animals are also there in the picture. Like that, you are written in the text form. Your model should generate automatically image of that. How it is possible? With the NLP and the generative. So from text to video and audio to video, image to video, these are all the different tasks, NLP tasks. So what you need to understand while building the model, you need to understand what is your natural language. Is it in the text form or audio form or video form? What is your? Then what is your goal? Then how to do that? Let's coming to the normal introduction to this NLP. It's a branch of computer science. It's a branch of AI. NLP, what does the NLP? It combines the computational things and the linguistics things, because need to understand the language. And this NLP is algorithms for understanding and generating speech, human readable text, generating speech and the human readable text. That's what the task. So it's going, NLP algorithm, a task is going to understand, and it will give, it will produce either audio or text or some other image kind of. So from natural language to structured information or the vice versa. That means natural language is always in unstructured form. It won't follow any particular structure when it comes to the this computing. So it converts into the structured information and the reverse. Yeah. So what it gives? It gives the ability to the machines. read, understand, and derive meaning from human language. Let me talk about this, deriving meaning from that. See, in research documents, at the end of the research paper, we'll find that the summary. So summary of the whole research paper, conclusion, summary, or overview. Maybe the document with a 10 pages or 20 pages, 30 pages. After reading the entire document and after understanding the entire document, it's going to derive the summary. That is called as summarization, text summarization. Text summarization is one of the NLP tasks, one of the major NLP tasks. It's many times this application used. Something like, I don't want to read the entire story about 30 pages. I want the summary only. Okay. Generally, who will prepare the summary? The humans, after reading and understanding the story, are going to write the short form of the story. In the same way, I need to develop a model which is going to understand, it's going to read and understand the text, then it's going to generate, it's going to derive the summary from that, conclusion from that. Okay. So in general, for application development maximum, we'll consider the text and the voice application. So based on that need, we'll consider the other applications, other tasks, other forms of the data. So generally, sometimes we'll call it as the computational linguistics. Okay. So it is like intersection of all these things. It's not required. So generally, the linguistic and spoken language, what it is, very big. Study of a spoken and written natural language in terms of an analysis of form, meaning, and context is the linguistic. The spoken language, when it comes to the spoken language, you need to spend some time on that. It's a physical aspects of speech sounds, study and classification of sounds. So in the beginning, I mentioned you can do some task on the voice. But suppose your input is audio, you process that. What kind of processing you are doing it here? The classification. For what? You want to understand the emotion level. So if I'm cool, my voice base is low. If I'm angry, my voice base is different. Or if I'm discussing something, maybe in an argument, my voice base is different. So what kind of task we are doing it there? It's a classification. So generally, the phonology is the linguistic sounds of the particular language. Is the phonology. So very brief introduction to the spoken and written language. So morphology is the study of the internal structure of words and forms of a core part of the linguistic study. And what are the morphological concepts, the basic concepts of morphology? One is the word, lemma, word form, stem, token. These terminologies are mandatory to understand NLP. What it is? Word, the smallest unit of language that is to be put in isolation. Examples: cats ran. Words are cats and the ran. Suppose you have a sentence, that is the word. What is the lemma? So any given sentence you can convert into the words. So this is a simple task, we'll do it. But that is not sufficient in the NLP case. The converted word should be in the dictionary form. What are those? Suppose cats ran. In that, the two words cats and ran. In that, cat is the dictionary form for the cats. Run is the dictionary form for ran. So what are the dictionary forms? We need to map it. So word form, the fully inflected surface from a lemma as it appears in the text. Something like cats and ran for ran. Are the word forms. Stem is a different one. Stemming is the process in NLP. We are going to discuss the stemming process. What is a stem? Part of a word that never changes. That means it's not possible to modify further. Cat for cats and ran for ran. What's happening here? Actually, in your text, cats is available, but you stem it to the cat. What kind of task you are doing it here? The given word, by removing some of the characters, you are converting the given word into this. Cats, in that S is removed and cat is the actual dictionary form. It is the stem of the cats. That means multiple words are derived from a particular word. And what is the stem word? What is the base word for that? Something like this. Program, programmers, programming, programs. All these are stem to the program is the base word. And the token is the smallest text unit in NLP. Smallest text unit is the token. Because while developing the NLP model, understanding the text, you need to convert the given text, large text, into the small tokens. What are those? What it is exactly? Maybe a word form is the token. Word form is a token. Or a number is a token. Or a symbol is a token. Similar kind of things. So we need to do the tokenization first before starting NLP. Let us look at, because here the multiple things are involved in NLP. One is the linguistic things. We need language expert contribution to build the model. Because if we want to derive a particular something like one model, mathematical model. So that model should be a meaningful. And when you are mapping that model to the language, you need language expert to decide that is acceptable one. And it's a combination of this algorithms, language, and the problems. So what are your problems? Maybe you want to parse the text, or you want to do the morphological things, or you want to tag with the POS, or you want to do some other task. These are the problems. In which language it is? At present, maximum of the research is going on in English language only, but there is a lot of task in other languages. Maybe those languages are low resource languages. In our Indian context, let us consider the Indian languages, the Indian local languages, the national language, and try to do research in the local language. Something like, suppose the Telugu document is available. You need to build a model going to understand the emotions involved in the Telugu text. So now the researchers are working on those things. How do you build a model? What are the algorithms are available? Maybe some of the algorithms like this: RNN, transformers, machine learning, statistical models. It's a combination of all these three. So maybe choose one task, and in one language, maybe one algorithm is required for you. Modeling of NLP is the modeling of human language with different techniques available. One is a rule-based NLP, another one is a statistical NLP, and the neural-based NLP. So advanced things are the neural-based NLP. My suggestion to the younger researchers, those who are yet to start or wants to learn the NLP things, don't go directly the neural-based NLP. You focus on the rule-based or the statistical-based NLP. Try to understand the statistical-based NLP. Then after that, you can extend your learning and this neural network based. Because the deep learning models are the black box kind. You need to understand the basics, and after that, you go for the next. Yes. So let us discuss about the varieties of NLP tasks and the applications. One NLP task is POS tagging. It is the process of labeling words in a text with their corresponding parts of speech. Suppose one sentence is given to the linguistic expert, easily can identify what are the noun words, verb words, adjectives, and adverbs. These are all. But we need to build an algorithm which is going to understand the grammatical structure and the meaning of the text. Now, this is the task. How to develop an algorithm or a model from the computing side, how to do this task, how to develop this. Any idea? What kind of task this POS tagging is? What kind of task it is? When it comes to the maybe the statistical are the learning algorithms. What kind of task it is? How to build a model for this task? Any idea from the participants? Even send your answer in the chat box. Are able to understand? The question is, the task is POS tagging. I want to build a model for that. I want to develop an algorithm for that. First, I need to understand what type of task it is and how to build. How the existing techniques, maybe the statistical and machine learning techniques, are useful for this task, for this purpose. Maybe machine learning techniques used. Yes, Astak is correct. Yes, machine learning techniques are used, but which kind of machine learning algorithm or technique is useful? Any idea? Yeah, I think no problem. No idea. This POS tagging, what you are doing? So this is the way how to convert some task, some idea into the problem statement, and how to prepare the objectives and how to design a solution for that. Look at this. So POS tagging. What is the task? Given sentence, you want to tag it. You want to assign a tag to each word. Exactly. It's a classification, correct? So each word, you have the multiple class labels. What are the class labels? Here, noun, verb, adverb, adjective. All these are all the class labels. Now you want to assign a class label, one particular label to the word. So it's a classification technique. Which classification technique is useful? Then based on that, you can use and even build your own model. Okay. Yeah. Let us continue. Next task is named entity recognition. It's a major task in the NLP, named entity recognition. Also used in other applications. What are the named entities? Let us see first. Names of individuals. So it is a process of chunking and extraction of entities from the given text. Now, what are these named entities? Names of individuals or names of organizations, or the location names and expressions of times, maybe the time period, and quantities, and the medical codes or percentages, monetary values. These are all comes under the named entities. And let me give the application. What is need of this? You know, to identify the named entities in a given text. Okay. What's the use of this? Maybe you want to build a search engine or a part of the search engine, something like the information retrieval. Suppose somebody is asking a question. I want the latest Apple computer, is the word, a sentence given. From that, identify the named entities. Apple is the named entity and the computer is the named entity. Based on that, your model is going to search for it and it will fetch that. It's information retrieval. Or if you want to classify the document, what type of document it is, based on the named entities. So identify the named entities and classify the documents. And other tasks are text summarization is another task. So in the beginning I mentioned process of generating the short form of the given text or summary of the longer document, longer text document. You have very long or large document with the 10, 20 pages, 30 pages. Read, understand, and generate a small text. The text summarization is the NLP task. So from the beginning, many times this spam detection was discussed, but this spam detection is also comes under the NLP task. It is a process of text classification. So it's going to read and understand the entire text, and it assigns a class label. What type of one? Is it fair, normal, or kind of text it is? What kind of text it is? Not only the spam, whether the email or a particular text belongs to the spam or not. Also, it's going to classify the text, the same text classification. We observed in Gmail, when you are composing a mail, is going to read and understand the mail body, and based on that, it assigns a tag. What type of one? Is it official communication, or it's a greetings kind of one, or it is a personal, or it is a type of one? Is it the email is the love letter, or a complaint kind of letter, or request kind of letter? What type of one it is? It classifies. What's happening there? NLP task is text classification. Then another important one is the sentiment analysis is also comes under the text classification. And other NLP tasks and applications are, one is the natural language generation. I mentioned that. So reading, understanding, and generating new one. Let me give an example where it is required. I want to write a new story. Okay. What kind of story? Maybe this action story I want to write, or I want to write a new story. That's a love story. But we are unable to get the new ideas, or in place of human, machine should do the task. What is it? It's going to read and understand a large number of stories. So train with the varieties of stories. You train the model with varieties of stories. Then ask the machine, write a new story that looks like written by the human. That is the storytelling machine. Still research is going on. Storytelling. So if the task is successful, so you can give the model to the something like the film industry, you can give, because it's going to generate the new stories, right? That is the language generation. And machine translation. In the beginning, I mentioned, I give an example of this machine translation. The process of automatically translating a text from one language to another language is the machine translation. I'm talking in English, but it's not reachable to the audience of different languages based on the source, based on the end user. My speech should convert it automatically into that particular. The process of automatically translating a text from one language to another language is the text translation. It's a machine translation. And another one is the speech recognition. So conversion of voice data into a text. It means when I'm talking, it should understand and then convert into the text. That comes under the speech recognition. Just a minute. Yeah. Sorry for the interrupt. Yeah, let us continue. So these are the different tasks. Suppose somebody wants to start building their own NLP application. What is the pipeline, end-to-end pipeline to develop a new NLP model? So that, as I mentioned in the beginning, you need to decide your objective. That is the end goal. Then based on that, identify the input sources. So what are the data, when it comes to NLP tasks, what are the sources? In general, maximum of the NLP tasks will focus on understanding the text available in the different microblogs like the Twitter, Instagram, Reddit. So I want to take the text. I want to understand why, what purpose. One is the sentiment analysis. It's an old application. Many people are working on that. But recently, myself and my research scholars started working on that. Reading the text data available in the microblogs and understanding the emotions involved. Emotions involved in that. That means emotion detection. So while sending a particular post, maybe the Twitter, so now X, when a user posting some tweet, what kind of emotion is involved in that? Okay. And what are the reasons? What is why a particular emotion is expressed there? Maybe the emotion towards the negative side. It's a negative emotions. And what is the reason behind that? So to understand the reason behind that, you need to do some other additional tasks. So what we started, the current research, what we are doing on this, we want to understand the emotions based on the mental status, mental situation. So what is the mental status of a particular person? Or what is the reason behind that? Something like when I'm posting some message towards the negative thing, something like I'm not happy, I'm unable to live, what is the reason behind my birth? Something like this. Today I'm very sad and feeling alone, kind of thing. The negative emotions. So what is the reason behind that? We started research on this. The person post one post, this a one tweet. Is there the stress level is something like the stress level is high? This stress level carried from the previous period. Maybe the period is a short duration, hour back or day back. Yesterday's tweet. Is there any stress is carried from yesterday to today? Because the today's expression, today's tweet is based on the previous tweet. What kind of stress is there in that? That is the previous kind. And not only one previous, you can have it the previous 2-3 days. Not only this days is the time based, just twist based. You can have the multiple twists, 4-5 previous tweets. So what is the level of stress in this tweet based on the previous tweets? Okay. Then we started working. With that, you can understand the emotion level of a particular person. And based on that, you can estimate the future decisions of a person. Future decisions based on this. You can understand. Okay. So that's the Twitter is the one. And like the Twitter, also we started working on the Reddit, maybe a kind of notes, suicide notes, or something like the negative emotion notes. Based on that, you can understand the person's mental stress, mental status. Then try to help to a particular person, a particular user. That's the application. Why we have chosen the microblocks as in major sources? Because everybody will express their inner feelings completely there only, and able to express their inner feelings in front of the friends, in front of the family members, in front of the parents and the other society. But they are good in expressing in the microblog everything they like. That's why we have chosen it, a good one. Then how do you understand it? Based on that traits, something like, with some action words or the some named entities, something like today I fought with boss. Today we had argument on a particular one. Something like today I got the promotion. It's a happy moment, the positive emotions. I got the promotion. Yesterday I got the salary. Yesterday I got the increment, the positive side, and the negative side. Then other text blogs and other resources. These are all the emails also you can use and understand the emails, what type, classify the emails and understand what type of it is. So extract the raw text data from these data sources. Here, this extraction of raw text data from the data sources, based on the type of the source, you need to develop your own. This module is maybe already developed part of this data sources, or you need to develop yourself. That's why shown it separately. For some applications you need to develop your own data extraction application. So it's going to extract the data. Whereas in case of these microblogs, there are the APIs. So based on the keywords, you can extract the data from the data sources. Then the text pre-processing and the feature engineering. So you need to pre-process the text data, because the text data is full of noise. There are many techniques in text pre-processing. We'll discuss that in the coming slides. Once the data is pre-processed, this raw data is converted into some other type. Now it is ready to process using some models. What are the models that are available? Statistical, machine learning, deep learning models are available. And you can choose the model. Model identification, model selection, and model building or training. Let me give an example. So in the beginning, I asked a question. That question was POS tagging. So that is the task. For that task, what are the models are available? Maybe the statistical and machine learning models are available. Which model in machine learning? Classification. Many classification techniques exist. Which classification technique is suitable? Maybe your something like the decision tree or Canaan and or some other naive-based classification or logistic regression. These are the models. So identify which model are suitable for this task. Then select one model out of that. Then start building the model based on the data available. And then the model testing with the pre-processed text data, you can test the model. If the model is working perfectly, you can do the model evaluation and validation. This is a bit different from the normal ML applications, well, ML models development. Because there at the model evaluation, suppose your model is the language model, okay, that means it's going to predict the future words based on the text, given text. So we are all using that. in online applications, starting from mail, the Gmail and other mail servers. So when you are typing some word, it's going to predict the next word. Okay. So when I'm typing good, it says that the good morning based on the time. When I'm typing the computer, so it's going to predict the next, maybe the computer program or computer science, computer system, computer language, which is the most suitable one based on the previous text. That is the language modeling. So major NLP system. So when you are building such type of language models, systems for language modeling, you need to evaluate in a different way. The normal evaluation is not. There are different measures to test the model. Okay, and the validation and the deployment. If it is perfect, working perfectly, then you can deploy it. Let us see. It looks like the normal pipeline, but let us see the individual modules, individual modules and components and its details, how to build that individual. So already I mentioned the few data sources, the Twitter and the Instagram and other use the existing APIs to get the data. So data sources without API, suppose you want to do some analysis on this, the in-house feedback system. Suppose you collected the feedback. You have a feedback system. That feedback system is the written one, maybe the written one, and you collected the written feedback. Or the internal feedback system collected the feedback in the form of the text. Now you want to analyze that. How many number of visitors are given the positive feedback and how many are given the negative feedback, and what kind of positive or level of positive and then the negative one. Now you want to understand that. You want to process the text now. How? Then follow the pipeline. So in the pipeline, already you decided the data source. Now your task is developing an application for data extraction, because no APIs for this, because it's your own system. Okay, or other microblogs. Suppose you want to summarize the microblog. What is written in a microblog, in a particular blog about a product? What kind of feedback, what kind of blog it is? Maybe you want to classify or you want to understand something from that. Well, if you want to develop such applications, you need to develop your own application for the data collection, because no APIs. Then text pre-processing. This is the major task in NLP. In this domain, the following two techniques are used. One is the text representation and the text processing. This is data representation and the processing. What is the data representation? It's the text representation. What is that? Conversion from numerical to the text to the numerical. Why? Why it is required? What is the reason behind it? For the NLP, maximum of the data sources are with the text. So your data is in text form. But when you're trying to build the model, your model will accept only the numerical data, because your model is a statistical model or the machine learning model. It accepts only the numerical one. Okay. So how to convert? The reason behind that conversion is this. But how to convert from text to the numerical? Yeah. Any idea how to convert text data into a numerical data? Transformation can be used. That's the process. Transformation is the process. But what is the exact task? Picture. We're not using the image. So it's not the image or something like, it's not the something like a character T and representing that using pixels and converting into that. No. Our task is text to data is given, but our model will not accept the text to data. That's why we need to convert into the numerical mode. Conversion is done, then the pre-processing. Let us see the conversion technique. Okay. The maximum of the researchers and the industry persons are spending maximum of their time for the data pre-processing. This is a text pre-processing. So this is the general representation. Suppose you have the given set of documents, text documents, D1, D2, D3, and so on, DN. That is your corpus. So multiple documents exist. Okay. So now the task is convert each document into a numerical one, into acceptable form. Let us see the tasks. Text representation and the pre-processing tasks. One is this one-hot encoding. Yeah. One-hot encoding, bag of words, and the TF-IDF. Then the tokenization. One-hot encoding, bag of words, and TF-IDF, and tokenization. These comes under the data representation. This is a text representation, whereas the remaining lower casing, tokenization, lower casing, stopwords, removal, stemming, lemmatization, and the normalization, these all comes under the text pre-processing. Let us see in brief each task. The common representation techniques, the one-hot and bag of words, and the TF-IDF, and the engrams is also comes under the text representation. Let us see what is that engrams. And first we'll go for the one-hot encode. So converting the text into the numerical using one-hot. It is the vector representation of text. Finally, we'll get the vector. What is that vector? What is the size of the vector? Let us say V be the number of unique words in the given text. So you have the large text document, maybe one page or one para. Let us consider a simple text is one para. Read the para, then do the chunking, partitioning it to the number, or read the para and find the number of unique words in that. Maybe 100 unique words or 50 unique words in one para. That's the V. Then what is the size of the vector? Is that V only. If you have 50 words, 50 unique words in the given one, and 50 is the size of your vector. The codification method to represent words independently in vector space is the one. Then represent each word in the form of vector. Those are the independent vectors. How to do that? Let us see. every word in a text corpus is assigned to a unique vector that consists of, it means if suppose in your corpus you have the multiple documents, if a document consists that particular word, so you can assign 0 to that, 1 to that. If it is a present one, not present, there's a 0. That means a vector with zeros and ones only. One-hot encoding vector consists of a single one, the rest of all belongs to 0 only. Suppose you have the 10 unique. Why like this? One and only one cell is 1 and the remaining are 0. The reason behind that is, suppose you have the 10 unique words. The word 1 belongs to the document 1. So it's not belongs to the other documents. That's why there, for one document is 1 and the remaining documents is 0. So that's the size of vector is same as the size of the vocabulary. Let us see the example. Suppose you have the sentence like this. This is my first NLP class. Okay. Now I want to convert into this using one-hot encoding. The number of words. This is my first NLP class. So converted into the unique words. The same, how many unique words are? The 6 unique words are. The size of vector is 6 only. Okay, size of vector is 6. And for this 1 and 0, 0, because that's the vector, and then is and my and first, this is a simple conversion. So let us take another example. That's the monkey. The monkey is eating apple or some other one. What it is exactly? Create a matrix of m by n by m, where n is the number of unique words and m is the number of words in the sentence. So how many number of sentences, how many number of words are there? That and unique. Right? Suppose these are the unique words. These words are repeated in different sentences. So red is repeated, red is 1, and whereas the pink 1 and the yellow 1 and the remaining. Just a minute. So another type of text representation is the bag of words. So read the entire text document and prepare a bag of words. And what is this? And how it is different from the previous one? There in the one-hot encoding, we are considering the position of that. But here, it won't consider the position of the word. Simply, you have a bag of unique words. That's all. And simply, all the words are dropped into a bag. And what is the idea behind this? counting the number of occurrences of each word in the given text document without considering its grammatical and the location, the supposition of the word and the grammatical role of the word. Just its count. So this is one way of extracting the features from the text. So in case of structured data, the features are the columns, right? Suppose your data is in the form of Excel sheet. So each column is one feature. You can supply those features to the model and do the processing. But here in NLP, feature extraction. Yes, this is the one method of feature extraction. So here, the count of each word, unique words in a bag and the count of each word is considered. That's the feature. So where it is used, this bag of words used in the prediction problems like the language modeling. You want to model the system, it's going to predict the future words. Or you want to do the document classification or the text classification kind of applications. In those applications, you can use this bag of words. So vector of each word is used as a feature because these unique words are identified and converted into the using this one-hot encoding, converted into the vector forms, and each one is a feature for training a model or classifying. This is an example. Suppose you have a sample message. So I've taken this one from the textbook, and I love this movie, and it's a sweet, but with something like the explanation about about a particular movie, maybe a review about that. Now the bag is prepared. It is a unique word. Its occurrence is 6 times in the bag. I is another word. Its occurrence is 5. So that means 5 times it's repeated in the given input data. Like this, one by one, how many times each word is repeated. So bag is prepared like okay. Suppose you have one blog or something like one para with multiple sentences, or in the corpus you have the multiple documents. Now I want to convert the bag of words with the encoding. Document 1, document 2, document 3. So document 1 is I watch the movie and I like it. The second document is I love the movie. The third document is I hate the last one-day cricket match. Something like this. These are the 3 different documents. Now each document consists these words. So I is the word repeated in all 3 documents. Okay. And watched only document 1. The from 3 documents. Then movie from 2 documents. Like this, converted into this is bag of words with the numerical representation. Suppose the extension is there. I watched the movie, I like it, it's a nice movie, and the music is good in this movie. The continuation, unique words will increase, then its occurrences in a particular document, document 1 or document 2 or document 3. So look at this, the third document. I hate the last one day cricket match. I, after that, hate the last one day cricket match. Whereas the is already repeated and it's not a unique word, already repeated. That's why its count is increased. So finally, unique words, its counts is the bag. So this unique word is I is 3 times and watch it is 1 time. These 3 times like that, the number of times each one. That's the bag. Then another way of text representation is TF IDF. It's a term frequency and inverse document frequency. So frequency of occurrence is the term frequency. How many number of times? So this is like a term frequency of term T in a document D. This is a T comma D. This frequency of term T in a particular document D. Inverse document is calculated like this. It's a log of number of documents by the number of documents containing a particular word. Total number of documents. What is the total number of documents? Is a N. The total number of documents in the given corpus. In the previous example, in the corpus, 3 documents are accessed. Suppose your application is the sentiment analysis, or your application is something like emotion detection. Each tweet, suppose you are extracting the tweets from the social media, each tweet or each post is 1 document. Got it? The total number of documents in the corpus. And term D belongs to the number of documents in that. There's a document D, it belongs to that, and the term belongs to the smaller document. Okay. So that means only 1 post. All the posts is the 1 number of documents. All the documents together is a D, and 1 post. A term belongs to that post is the D. IDF is calculated like this. IDF of a particular term in the given corpus D. In the given corpus D. It is calculated log of total number of documents by the documents. That's a number of documents where T is up. Now this is a TF IDF score. Is a TF is separate and a TF IDF score is used. This is another way of representation. And it is used to understand the significance of a particular one. How it is calculated like. Let us see. TF IDF of this term T, smaller document D in the corpus D is equals to term frequency of a particular term in the document D, then this one, the dot, this dot product, then IDF of the IDF of the particular term under the. So it gives the weight in the TF IDF, shows the significance of the particular term. Let us take one simple example and let us find the significance of that. Eat apple, this is the regular text example I have taken. Eat apple, eat bread, eat food. So 3 documents. Eat bread, eat apple, eat food are the 3 documents. Unique words are eat, bread, apple, food are the unique words. Okay. The term frequency. Eat frequency in the eat bread is 1 time. Its frequency is 1 time only out of 2. 1 time occurred. Eat occurred in 8 apple 1 time out of 2 times. Out of 2 words, 1 time it's. And eat is 1 out of 2 total number. This 2 are there. Eat food and other. Then bread. Eat bread, eat apple, eat food. Eat bread is 1 by 2 because the bread is occurred 1 time in this document, whereas bread is not occurred in apple, bread is not occurred in food. That's why 0 by 2. Out of 2 words, 0 number of times this bread is occurred here. This entire one is like that. The same apple is also same. So only appeared in eat apple document, whereas in the other documents its frequency is 0. And the food is occurred in the eat food, and whereas the other documents is 0. Okay. IDF. It is the total number of documents by the number divided with the number of documents a particular word is. Then log of this. See, eat is a part of document 1, document 2, document 3. So it's a log of 3 by 3. Then bread is one time eat bread. That's why it's 3 by 1. Whereas apple is also one time occurred in the and 3 by 1. Then the food is also the same. That's why this frequency IDF scores are 0 and the other 0.4. This is the way of calculation of this IDF. And let us use the IDF and the frequency. This is a multiplication dot product of IDF and frequency. Then identify the significance of the word. Eat bread, apple, food are the unique words. In eat bread document, okay, eat frequency. This is a 1 by 2. And what is the IDF score? IDF score is 0. That's why it's 1 by 2 divided with 0 is value 0. And whereas the bread and the apple food, in the bread case, is a 1 by 2, and it's this IDF score is 0.44. Bread IDF score is 0.477. Whereas the apple, this in the eat bread document, apple significance is 0 because it's a 0 number of times appeared, and it's what is that? The apple IDF score is 0.477, but whereas frequency of apple in the eat bread document is 0. That's why its value is 0. The food is also same. The food occurrences in the eat bread is 0, and 0 multiplied with 0.4477 is 0. So in the first one, the eat bread, only the bread is having significance, whereas the eat apple food significance was 0. Eat apple, eat is significance is 0, and the bread is 0, apple is 0.23, and whereas the food is also 0. Eat food, eat is 0, bread is 0, and apple is 0, and food is 0.237. So finally, with this one, the text to data, you represent the numerical form, and you can give this as an input to your model. Okay. Yeah. And the tokenization. In the pre-processing, before pre-processing, you need to partition the data, given text data, into the number of chunks. Is the process of splitting the raw text into small chunks of words or sentences is called the tokenization, and those sentences are words are called the chunks. Remember, in some cases, this tokenization process is converted a large document into the number of sentences, not the word level. That is also a tokenization. Yeah. From the tokens, get more insights into the text using the statistical tools and methods. So you can pass these tokens as an input to your model, and you can do the processing. And generally, the two types of tokenization, as I mentioned, the word tokenization and the sentence tokenization. We know that the space-based tokenization, based on the spaces we are going to consider, or some other representation. It is up to you. Then the text normalization. So the text normalization is the process of putting the words and tokens in a standard form. In a standard form, that means in the acceptable form. Transforming the text or a word into a single canonical form is called the normalization. Or improving the quality of the text or making it suitable for the machine process is the normalization. This text normalization can be achieved with this from the following two techniques. One is encoding and the tokenization. It is the process of converting the meaningful text into the numbers or vectors, or the tokenization is the process of splitting into the number of basics. With this, it is achieved. And stop words removal is a normalization. That means the given text is converted into the tokens, and in the given tokens, some of the tokens are not useful. What are those? Identify and remove. So we have seen the bag of words. In that bag of words, a more number of times I, the are occurred. Is there any use with those words to understand the given text? No, no use. That's why remove those words. Remove the stop words. Stop words are set of commonly used words in the language, things like a, the, is, and so these are all the things, and it is automatically removed. Typically, articles and pronouns and the prepositions, pronouns and adjectives, these are considered. Removing the words that occur commonly across the documents in the corpus is the stop word removal. Removing low information words from text and focus on the important words. Then improves the what's the need of this? It improves the search queries. Suppose you have given something like your NLP application is the chatbot. So it's going to communicate with you. So when you're asking a question, it returns some answer to you. On what basis? Your question is going to convert into the number of tokens and identifying the important tokens. Then searching based on the important tokens, and in that way you can improve your search process. So when you are removing these kind of less information words, your unique words, the count of unique words will go down, and your matrix size or the vector size is small. So then automatically processing time is less. It takes less time to find. And another normalization is the case conversion or the lower casing. Converting the uppercase into the lower case. Why? Why to do? What type of computer science problem we are solving using this? See, in the previous example, I have seen that unique words in the given text document and converting those unique documents into the vectors. But when you are considering a word with the capital letter, the small case letter, it's a combinations. The system considers each one as a separate word. With that, when you are considering each one as a separate one, then the number of unique words count will increase. When the number of unique words count is increased, then automatically vector size is increased. Also, that creates the data sparsity problem. Okay. So lower casing solves the data sparsity. Let us see how it solves the data sparsity problem. So here the original word is NLP, NLP, NLP. See, the three forms word is given. N is the capital LP. All three capitals NLP, NLP, NLP. Are all three are the small. So when you are converting this into the this what is the text representation into the vectors, so each one looks like a separate vector. Each one looks like a separate word. Now we need to convert into each word is converted into the small case. NLP, NLP, NLP. So when this N is converted into the small case, and all three NLP is also converted. So when you are doing this conversion, all three words looks like a single word. So instead of 3 by 3 matrix, a single vector 3 is enough. So the data sparsity is, this is number of zeros are reduced and addressed data sparsity problem. Stemming. So in the morning I mentioned stemming is the process of converting the given word to its original form. So it's the process of reducing inflected form of a word into a stem word. The process of reducing the inflection word. Process of reducing the word to its stem, and generally it's a canonical form of the original. What does it? It removes the suffixes. It removes the suffixes and from the original word and useful for the information retrieval. That's what it is. Because in information retrieval, the document is represented by vector of words or the terms. Then automatically, suppose you have the multiple words with the different spellings, something like the programs, programming, programmers. These are all. So removing those suffixes, finally it looks like a program related. Okay, so use only that as an input, and then it improves the system process. What is that? The information retrieval. So these are some examples. Troubles is mapped to trouble. Dancing, danced, dancers, dancer, dances, dancing. These are all converted into dance, comes under dance only. So when a given query with these kind of words, and it's going to map to the same one because the stem is the same. So all the documents with this stem word are extracted from the source. Other examples. Yeah, look at this. Look at the last example. Replace, replacement, replacing. So when you are removing the stem words, this is suffixes, replacing is ing is removed, replace, and replacement, this ent is removed, and replace e is removed because that's the stem word for all these three words. But this stem word is without any meaning. Reply, is there any meaning for the reply? No. What is the reason? It's not a dictionary term. This word is not the dictionary term. So we need to map to the dictionary terms. So that is the lemmatization. When it comes to the stemming process, different algorithms are available. We're not going to discuss these algorithms. Lovin's algorithm, Porter's stemming algorithm, and the snowball stemmer, and the Lanskis, this stemmer. These are all the 4 different stemming algorithms are available, popular stemming algorithms. So we're not discussing those. So these are all connected connections, something like that. That's the example. Stemmed words. So similar to the stimulus, that's what the lemmatization, it tries to do the proper way, and it transforms the words to the actual root form. And lemmatization has a predefined dictionary. So each term is going to map to the dictionary terms. Okay, how it's going to map it? One term is mapping to the other term. Then again the same basic process. What is the word? Whether both the words are the similar or some similar or not. So finding the similarity between the words, then deciding what is the closest one. This is the stemmed word, and this for a particular stemmed word is the closest dictionary form is this. Then replacing with that. Okay. Look at this: the troubles, and all are replaced to the trouble. And when it comes to the troublesome. So detailed process discussed in different research papers. Normalization, also discussed previously. So this is it's an additional one. In addition to the actual the different techniques we discussed in the normalization, also we need to do the other kind of normalization. That is a canonical form. It's a transforming a text to its canonical form. That is the standardized form. Because in social media, maximum of the data sources are the social media. When you are extracting the data from social media, or there in the social media, they won't follow any dictionary forms. In general, they will write abbreviations and the misspelled and something like the out of vocabulary, this kind of things. Okay, let me show you some examples. Look at this. So in a social media, a particular document, good is there, but whereas in the normalized form, because in the dictionary, so when you are mapping this good to the different dictionary terminologies and dictionary words, and the most nearest and most similar is the good, and replace that one with the good. And GUD, good, is another one, and its replacement is good. Actually, before it's written, so actually it pronounces that's a before. And tomorrow, and replaced with the tomorrow. Normalized forms. Yeah, US tagging also done. This is not required. Yeah, any questions? Because I want to show you one, I want to present to you one example. Till now, any questions? Yeah, no questions in the chat box also. Yeah, wait for 2 minutes. I'll continue after that. I'll present one application to you. that the models are useful for that, then how to build a model using that. Okay, just wait for 2 minutes.
Hello, good afternoon, everyone. There is a break of 5 minutes. And relax for 5 minutes. After 5 minutes, the sir will be back again. See you.
Hello. Is it audible? Hello. Hello. Good afternoon, sir. Sir, my screen is visible? Sure. Not visible. Yeah, shared. Okay, right. Yeah, let us continue our session. Now, from the morning onwards, just I have given the brief introduction to NLP and the different NLP tasks and the NLP applications. Then the NLP, there's a text pre-processing. So we discussed all the text pre-processing techniques. Okay, let us see two simple applications. Application one is, first I'll move to the task. So look at the text given to you. Something like it's a hockey. There are virtually no surprise, and the writing is second rating, and so why was it so enjoyable? Something like this. So this is the text given to you. Now you need to build a model on this text, for this particular text. Purpose of building a model is classifying what type of feedback is given it here. What type of feedback? Classifying the entire one. This is also a textbook example I have taken. What type of one it is. So what is my task? Classifying this text. So it is a classification process. So what are the techniques are available when it comes to the classification? The different learning techniques are exist. The statistical and the machine learning techniques are exist. So I want to use the logistic regression for classification. So I'm not discussing the details of logistic regression because that is not in this session, and because it takes a time for that. Those who are completely new for this, for them, 2 minutes. Yeah, drawing tools. So in this logistic regression, what I'm going to do, I'm going to build a model. That model predicts the probabilities between 0 to 1. This is 0 and this is 1. Okay. So my probabilities are always between this with the help of the sigmoid function. So here, suppose this is the mid. If my value is below the threshold, threshold is 0. 0.5. So this is 0.5. Above the threshold value comes under 1, below the threshold value comes under 0. So what I'm modeling, simply I'm modeling and I'm predicting y values based on the x values. Okay, so something like the linear, it's x plus b kind of one, but this is not the x. So here I'm going to predict these probabilities. That probability is 0 to 1. If it is 0, 0 is this and 1. And mapping this one to the classification. What type of classification it is here? It's a binary classification. Binary classification, 0 or 1. 0 means maybe negative. 1 means maybe positive kind of. I want to classify the text into two, either positive text or the negative text. So more details are not required. Now, what about the strict regression? Look at this. Logistic regression will accept the different features x1, x2, x3, xn. Those are all comes under the x. And predicting y values, this is y is 0 or 1. So we are passing this x1, x2, x3, xn and the bias value 1 as an input to the sigmoid function. Okay. What are these? These are the features. x1, x2, x3 are the features. W1, W2, W3 are the weights associated with the features. Who will assign these weights? So generally automatically learning one thing, and another thing is externally passed, supplied by the end user. So we are passing this weighted features, features and weights as an input to the sigmoid function, and it produces either 0 or 1 binary. Okay. Now, what are the features in this document? In this text document, what are the features? Features are some of the words related to the positive, words belongs to the negative, words belongs to the neutral, and words belongs to some other terminal. So look at this. X1, x1, x2, x1 is x1, x2, x3, x4, x5, and x6. What are these x1, x2, x3, x4, 5, and 6? Look at the x1. The count of positive lexicons belongs to the document. In the given document, how many number of positive lexicons are exist? 3 positive lexicons. See, x1 belong. This is the count of this. How many? 3. Look at this. Great, nice, enjoyable. These are all comes under the positive. Okay. And the negative, x2, are the negative lexicons. How many such negative lexicons are exist in the given one? 2 negative lexicons are exist in this one. Now x3 value is 1. Okay. If no belongs to the document, these are my rules. Okay. x3 value is 1. If no belongs to the document, if not belongs to no is not belongs to the document, then its value is 0. Okay. Then x4 is another feature. Count of first and second pronouns belongs to the document. How many number of first and second pronounces exists in this one? That is the x4. Look at this. I was overcome with the argue to get the of this, something like this, and it shocked me. I, me, you are the second and third pronounces. First and second pronounces, and the number of second this first and second pronounces are 3. Okay. Then x5 is a different feature. That x5 feature is 1 if this particular symbol belongs to the document. Surprise kind of thing. If this is belongs to the belongs to the document, then the x5 value is 1, otherwise x5 value is 0. Then the last one is 6, x6. Last one is 6. This is L of number of this word count of the document. So this is number of words in the given document, applying the log value to that to minimize the size, to minimize the value. So applying the log value. So total number of documents, total number of words in the given document are 66, and log of 66 is 4.19. Right? These are the features. Now what we have done, we have taken the text, identified. To identify these kind of words, you need to do the tokenization or chunking process, then mapping to the dictionary, because you need a dictionary. There you are going to map your words to the dictionary and checking whether it's a positive or negative kind of one. Negative words or positive words to dictionary, and if it is matching and comes under the positive and negative, and also other simple pre-processing. With that, you achieved to this state. Now the current state is, so your values, these are the features and its values, corresponding values of this. Now you can pass these feature values. X1 values 3, X2 values 2, and X3 values 1 as an input to the sigmoid function. Look at the previous one. This is sigmoid function. X1, X2, X3, X4, and X5, X6 values. Total 6 values are passed as an input. But these values are associated with the weights. Each one is having, each one is associated with this. These weights are associated with each feature. Okay. How do you get these weights? One is through the learning process or the external thing. Assume that now in this application, we are assuming already learned real value weight for each of these 6 features. So we identified 6 features and already learned these 6 features. The weights are already learned. Okay. Yeah, let us see the values. X1 values 2.5. That means I want to give more weightage because in the learning process, this one having the more weightage, and the negative one is this value minus 5.1 and minus 1.2 is the third feature. 0.5 is fourth, and the remaining features something like 0 and 2.0 and 0.7. 1, 2, 3, 4, 5, 6. Total 6 features. Now the bias value, assume that the bias value is 0.5. The weight W1 indicates the importance of positive lexicon words. The number of positive lexicon words are 3, and is the positive sentimentation. And W2 indicates the importance of the negative lexicons. These are the learned parameters, learned weights. The weights and the corresponding features are passed as an input to the model. Note that the W1 is a 2.5 is a positive, while this one is negative word or negatively associated with, because this is the positive one and negative one with a positive sentimentation, and about that is the importance of this. Now let us calculate the Y values, Y probabilities. So this is the X is based on the X, Y belongs to the positive or the negative. So this the plus means the positive based on X, or Y equals to 1 based on X. So this is the sigmoid function, sigma of Wx weights. This vector of weights, X is the vector of features. So vector of weights 2.5 minus 5.0 and so on, 0.7. Then the dot product with the X. So 3, 2, 1, 3, 0, 4.9 are the vector values of this X. Then plus this bias. Okay, bias is 0.1. Then based on this one, we calculated the sigma of this is 0.8, and then this its value is 0.7 around, and the to get the negative one, or to get the minus side, or to get the 0 side, it's a 1 minus simply this positive value. When you are subtracting this 1 minus this value, we'll get the remaining, what is this, 0.3. So 0.3 is the negative one, and the 0.7 is the positive one. Finally, the given document or given text belongs to the positive text. Okay. Yeah, that's the one example. What is that? Reading one text and deciding what kind of one with a simple statistical model. Based on that, you can classify what type of text. Then I want to give another example. Another this application is the language models. There are many language models. We're not going to discuss all. Only one simple model, that is the N-gram model I discussed. So what is the purpose of these language models? These language models will predict the next word in the sequence. That means already you are using those. So when you are typing some word, so it's going to predict what is the probability of next word. What is this? The next word is going to. So language models assign a probability to the word in the sentence. Get it? Probability in the sentence. What is the occurrence, chances of occurrence of a particular word? How many types of language models? So statistical language models are the n-gram models. I'm going to present n-gram models. And the neural language models are the neural networks based. There are different models. So you need to understand the basics, and then later on you can continue in the neural language models. Because for that purpose, you need neural networks basics and other concepts are required. So n-gram model, simplest kind of language model, models that assign probability to upcoming words. So the n-gram models are going to assign the probability to the upcoming models or the sequence of words. What are the sequences? It calculates the probability of a given sequence of words occurring in a particular sentence. So language models, applications, next word prediction. What is the next word? Also, you can do the machine translation, translating from one to another one, and the spelling correction. Suppose the given spelling is not correct, then automatically it's going to correct. That's auto spelling correction. Then authorship identification. Now the research is going on this authorship identification, because who is the creator of this particular post or text or blog, and the natural language generation. In all these applications, language models are used. In n-gram model, an n-gram model is a sequence of n words. How many number of words? How many number of words? Suppose n is equals to 1. It's a unigram. That means only one word. It's a single word of sequence of words. Whereas the bigram, n equals to 2. Two words are used. N equals to 2 is a bigram, is a 2-word sequence of words. Something like this. Please turn your homework. Something like this. These are the two words in this one. N equals to 3 is the trigram. Is a 3-word sequence of words like a please turn your homework. So three words are considered. Let us see how to build the model. What is the goal of this model? Computing the probability, assigning the probabilities. So compute the probability of a sentence or a sequence of words. How do you calculate? So W is the number of, capital W is the word 1, word 2, word 3, and so on, the number of words. So probability of the word W is the probability of the individuals. Okay. So here, when you are calculating the probability. What is the occurrence of, what is the probability of occurrence of the next word after this? Suppose probability of an upcoming word W5 for the given words W1, W2, W3, W4. What is the probability of upcoming? That means in a given sentence, W1, W2, W3, already W4 are already there. So what is the probability of occurrence of the next word based on this? That is W5 based on the 1, 2, 3, 4. A model, that's a language model that computes either of these probabilities. It means probability of nth word based on the probability of n minus 1 words. So this is probability of W1 plus W1, W2, 3, 4, 5, 6, and so on. N minus 1. That means probability of, based on the n minus 1, you are going to predict the occurrence of the next word. So in this way, you are going to train the model in the given purpose, in the given training data, this many number of times word 5 is occurred after first 4 words of this kind. Let me continue. Few more basics. How can we compute the probability of the entire word sequences like the W1, W2, W3 using the probability of the word sequences? The probability of this. This is calculated based on the conditional probability. Okay. So let's take an example. Conditional probability. Probability of B by A equals to probability of AB, probability of by divided with probability of A. So this is converted like this. Probability of AB together equals to probability of A dot product with the probability of B by A. Got it? No need to spend more time because this is normal probabilities. Now the probability of ABCD, correct? That means more number of words. So probability of ABCD equals to probability of A, probability of occurrence of B based on A, probability of occurrence of C based on AB, probability of occurrence of D based on ABC. Dot product of all these is the probability of this one. Okay. That is the conditional probability. So this is the general chain rule, what we call. It's a probability of W1 to Wn is probability of 1 to 3, the same thing. Okay. Yeah, this is same what we discussed. Count of, it's a simply probability of Wn is based on W1 to W3 and so on Wn. So it is the count of probabilities of all these things divided with the count of probabilities of this n minus 1. Okay. Now look at this. So here, in case of the unigrams, so this is probability of 1 to n minus 1. This is a probability of W1 based on this rule. It looks like the simple probability of Wn only. That means the last word only. But that is not sufficient to find the to predict the next word. So what is required? Bigram is the most suitable. That means Wn is based on W up to Wn minus 1. See, W5 predicted based on the W4. W4 is predicted based on W3. 3 is calculated based on the 1. So simply, it looks like up to n minus 1, Wn minus 1. So W1, 2, 3, 4, 5, n minus 1 is calculated. That is, up to n minus 1 means the probability of n minus 1. So Wn is based on n minus 1. In case of trigram, it's Wn minus 1 and n minus 2. 2 words are considered. The last 2 words are considered to predict the third word. In case of n minus 1 are considered. Okay, this is the one. Let me what this is the calculation, right? This is sum of all these things. This dot product of all this. Not required. So let me give an example here. Suppose the sentence is like this: the man from GPREC came, and the probability of the, and the probability of man, probability of from, and probability of this, like this. It's in case of the bigrams. And let me jump to the bigrams. Bigrams is the 2. See the this S and slash S are the something like the terminators, beginning of the sentence and ending of the sentence. So how many number of times in the corpus, in the learned data, how many number of times the is the beginning of the sentence? That's the meaning. The based on the yes means the beginning of the sentence. And the next one, next diagram is the man the. How many number of sentences man is occurred after the? Okay. And the next one is a from man. How many number of in the learned corpus or given corpus? How many number of times the from is based on man? Okay. Trigrams 3. How many number of times occurred in a sentence? These occurred in a sentence at the beginning and ending. That is S and S. What is the probability? And how many number of times man is occurred at the beginning of the sentence, after that the and followed by man? Let me give a corpus, a bit more corpus. Let me move to the next one. These things, I'm skipping a few things. Yeah, directly I'll talk about the example. Okay, look at this. A mini corpus is given. Each sentence with a special symbol at the beginning S and ending is slash. But actual given corpus or extracted corpus is that only. I'm Sam and Sam am and I'm fly, something like that. At the beginning of the sentence. And to give us the bigram context is the first word and the special symbol is ended at the end of this. Okay. Now these are the correct, these are the symbols are added to that. Unigrams is only I am, Sam, fly are the unique words in the given one. Okay, right, unique words. Now let us consider the bigrams. S and slash S, beginning and ending. Those are also tokens in the tokens because the corpus is the corpus extracted and to the corpus these are special symbols are added. That's why those are comes into the tokens. So total number of 6 tokens, 6 unique tokens. I am, Sam, fly are the 4. In addition to those 4, 6 is also a token. Okay. So total number of bigrams. How many number of combinations you will get? 6 multiplied with 36 bigrams. Let us see what are the bigrams. So what is here? First one, look at the first. Probability of I at the beginning of the sentence. Yes, probability of I at the beginning of the sentence. So what is the probability? Total number of documents. How many? 3 documents. Out of 3 documents, in how many documents I is at the beginning? In 2 documents, I is the beginning of the I is at the beginning. So that is I am Sam and Sam am and I. Out of these 3 documents, 2 times 2 documents. This is 2 by 3. Okay. Now, what is the probability of this? Probability of yes, that's a probability of Sam. At the beginning of the sentence, total 3 documents are given. Out of 3 documents, only 1 document consists at the beginning. Sam is at the beginning, only 1. That is the probability. Whereas am at the beginning, 0 number of documents. So am is not the first sentence, the first word. Okay, and fly is also not in the given corpus. Fly is not any word is this, any sentence is not starting with the fly, and whereas this, look at this. What is the probability of this statement, this word, this token S at the S? So in the given corpus, no null sentences. That's why it's a probability 0. And how many documents? In how many documents starting symbol is appeared after I? How many documents am appeared? This starting symbol is appeared after am. How many number of documents? This value 0. See, look at this. The last what is 1, 2, 3, 4, 5, 6. 5th column is completely 0 because S itself is the starting symbol. It's not following any other symbol. S itself is the starting one. Okay, that's why it's a probability. But look at I. In how many documents I is followed by I? Is 0. Like that. Am is followed by I twice in the given corpus. Fly is followed by I once, and then here the next one. This Sam is followed by am is 1 time. Then am is at the beginning, at the end of the sentence. That's the end of the sentence is appeared after am. That means what is the last word in the given sentence. So these are the calculated probabilities for the given corpus, right? Now the corpus is ready. Once the probabilities are ready for the corpus is ready, and the probabilities are ready, diagram probabilities, then it's going to model. What is that? When you are typing I am, then out of 3 documents, or when you are typing I, out of 3 documents, 2 documents I follows am, then automatically it's going to predict the next word as am. Fly is also there, but the probability of fly is less. So you need to decide which is the next word is the am or the fly. So it's going to predict automatically. Okay, and same when you are typing Sam, then it asks you close the sentence, or it's going to predict the am Sam, the kind of I is the next word. So this is very simple example. So based on this example, you can apply to the other things in this n-gram model, especially this bigram model, or you want to apply the trigram model and then calculate the probabilities and keep the probabilities with the model, and based on the probabilities is going to predict the one. But in general, see, the last 2 words are most suitable to predict the next word, but when you are calculating the probabilities, the last 3 words and the previous 3 words, it is a bit complex. So n-gram model is very simple but bit complex thing, and that's why on top of these n-gram models, what is the neural network based models got the popularity, and because of its perfectness, and it's going to predict correctly, and it's going to reduce the number of computations. So yeah, this is the one. Yeah, suppose one database is given like this. See, this is about, there are 9,222 sentences in the corpus. This is the Berkeley restaurant project sentences. So in that corpus, these many sentences are available. So raw diagram count for 8 words is out of this number of, these are the just 8 words are considered out of 1446 words. Those are the unique words. Out of those unique words, and these are the calculated probabilities. I to I is occurred 5 times, and this I want, I followed by want occurred 827 times, whereas I followed by eat, I2 is 0 times, because nobody written such sentences I2 kind of fun. And I Chinese, I food, I lunch kind of fun. I spent out of those many number of sentences, 2 sentences, this is I2 spend kind of like this is the corpus, and based on these probabilities, and is going to predict what is the most probable word. Something like want is the one. Want I is only 2 sentences. Want to 600 plus sentences are written. That's why it's going to predict the next word is 2. So this is about my presentation. What I planned here, just to give the brief introduction to the NLP. What are the NLP tasks? What are the NLP applications? How do you build a model? What is the pipeline in that? And each component, what kind of tasks are involved in pre-processing, extraction, or how do you identify the model based, and what are the parameters you need to consider to identify the model, and then based on that, you can build your own NLP task. There are other tasks like the last component was not discussed, that's the validation. So this language models validation takes more time, because the different functions exist. Based on that, we need to validate whether it is working perfectly or not. So for this 2 to 3 hours is the maximum content possible, and that's why I covered. Any questions before closing my session? Let me take questions. Any questions? So coming to the research directions, while discussing the topics, I mentioned some of the open research problems. So you focus on that, something like we need to, there is a need for the local languages and the especially local language based emotions identification, and then the translation, it's happening, and still need some more additions to the machine translation. And the suggestion, one suggestion to the young researchers, don't start directly the deep learning based NLP, because all these deep learning techniques, LSTM, GRU, and BioLSTM, BioGRU, these are all the well-established models, and will does the task immediately. And also, what does these tasks? It hides many of the computations, especially the pre-processing. It won't tell exactly how the pre-processing was done. And also, those models are not explainable. That's why beginners start with the basics, especially the beginners start with the the statistical models and machine learning models. Yeah.
Okay,
Thank
thanks a
you.
lot, sir. Thank you a lot. If there are any questions, anyone, you can pose your questions. Otherwise, we'll stop the morning session. Thank you. Thanks a lot, sir. It has been very good session, sir. Very informative, very knowledgeable session. Thanks a lot, sir.
Thank you. Thank you, sir.
The afternoon session will start at 2 o'clock. I request all the participants to rejoin at 2 o'clock after the lunch. Thank you. Thank you, everyone.
Okay, sir. Thank you. I'm leaving.
Okay, sir.